Hello, let's continue our Sudoku adventure with Tall Sums by PjoeterBliep. So this continues our Escape the Grid theme week. Hope you're enjoying that. So we've got lines escaping the grid, making us place digits outside the grid. All right, let's go over the rules. So we have normal 6x6 Sudoku rules, meaning in each row, each column, and each 2x3 box, we are placing the digits 1 to 6 exactly once each. Now the stuff outside the grid is not counted towards our Sudoku, just to be clear. We also have skyscrapers. So if a digit is outside the grid, and we are going to have to place digits where these lines end up. You don't have to place them anywhere else, nor should you. These are skyscraper clues. So let's say this was a 3. What that means is, say you were standing on top of this 3, looking down this column this way. This counts how many skyscrapers you can see, where the digit in the cell is the height of the skyscraper. So say this was a 2. We would definitely see that. You always see the one right in your face. Now, let's say this was a 4, you would definitely see that because a 4 skyscraper is taller than a 2, so it can be seen behind the 2. But if I put a 1 here, well, both the 2 and the 4 are hiding the 1, so we do not see that 1. And so another way you can think about this is the digit has to be larger than all of the previous digits, every single one of them. And so now this could be, say, a 6, and then this could be our 5 and our 3. And you can see, we see the 2, the 4, we don't see the 1, we see the 6, and we can't see the 3 or 5. Once you hit a 6, it hides everything else. So, because 5 isn't bigger than 6, 3 isn't bigger than 6, right? So if we count the green cells here, we have counted 3, and that is the count filled outside the grid. So that would be one valid way to fill that column. There's lots. All right, and we also have these blue lines in and out of the grid. Blue lines in the grid are region sum lines. Lines are split into segments by box borders. Within each individual line, the sum of the digits on each segment is the same. The sum of segments on different lines may or may not be equal. So that's just saying, hey, it only affects the line that it's on. The sum can differ per line. So let's segment this here. So every time we cross a box border, we are segmenting our line. So we have this segment here, here, and here. And whatever the sum is of any segment on the line is the sum of all the segments on the line. So all the segments have the same sum. So say this was 1, 2, 3. This could be 6. This could be 6. And this could be 3 and 3. And even though it's red marked, it is allowed to repeat digits outside the grid. Cool. So that could be correct. Just a flaw in the way conflict checking has to work within the way outside the grid ends up working with Sudoku Pad. It's complicated, but don't worry too much about that. All right, cool. And that's it. Those are the rules. There's a link in the description if you'd like to try the puzzle yourself, and I'm going to get started right now. All right. So actually what I did here must be true other than the 3, 3, because we can't repeat any digits on this line or within a box, right? So you don't repeat digits within sums except if they're outside the grid. And so 1, 2, 3 is the minimum, which is 6, but the maximum I can put in this cell is a 6, largest digit in the puzzle. So we end up being 6, 6, 6, and then these two add to 6, using 1, 2, 3, 4, 5 in some way. But actually we know immediately that this is a 1, because as soon as a 6 is blocking the vision, we don't see anything else. We just see the 6. And that makes that a 5, meaning we're seeing everything except one skyscraper. So we can pencil this. It's kind of like penciling a thermo, but it's not quite as powerful as penciling a thermometer. So how are we penciling this? Well, what is the biggest digit that could go here? Obviously, we could put a 1. We can put a 2. The 2 is going to hide the 1 wherever it is, but we could go in order otherwise and see 5 digits. But if I put a 3, no matter where I put this 1 and 2, they are going to be hidden by the 3, meaning we've hidden 2 digits, so our count is maxed at 4. So this is 1 or 2. Now, this cell here can be 1 higher. It can still be a 1, but it can also go up to 3. The reason it can be 1 higher is we are seeing this cell. And so if this were a 3, it's not blocking this one. And so it's only going to block the other 1 too, meaning we can still fulfill our 5. And so we end up increasing by 1 as we go by that logic. So this is 1, 2, 3, 4, which makes that 1, 2, 3, 4. And this is 1 through 5. And then the 6 ends up over here somewhere. Okay. Now these are just the same digit because the 1 cell region sum. So these are, the 6 is placed in this box. This is a 4, 5 pair. This is 1, 2, 3 with the 3 down here. The 5 ends up here somewhere. That doesn't seem to be a problem. This is a 6. Oh, sorry. So a 6 skyscraper. I didn't notice that. The 6 skyscraper forces 1, 2, 3, 4, 5, 6. So that's a 3. This is a 1, 2 pair. That places 3 in this box. That's 2 and 1. All right. Let's see. So these add to 6. Notice that this is a different segment than this, which is different than this, because crossing a box border creates the segment. So these add to 6, but I mean, with 1, 2, 3, 4, that means there's no 3 on it. It has to be 2, 4. Okay, that's a 1, 3. Now these add to 6. We don't know much about that. We know it doesn't involve the 1, because the 1 would require a 6 here for the skyscraper. And so it's either going to be 2, 4 or 3, 3. Over here, this can't be a 1, but this could be. So let's hold off on that. Oh no, these can't be 6s because there's already 6 in a row, right? 6 is actually placed right here. So because these can't be 6s, we're also down to either 2, 4 or 3, 3. This is just a pair. This is a 4, 5 pair. Oh, this is also 4, 5 for the box. So that makes this the 1, 2, and that makes this the 5, 6. Okay. So this is block. This is going to block all but the 6 potentially. So we could see at most 4, but that's what this max is at. We can't see just 2. Can we? Oh no, we can. This can be 4. This can be 6. Okay, never mind. That works. So we've got 1, 2, 4, 5 here. I don't know if I want to mark that. Is there anything else to think about? Maybe I have to think about this column. Yeah, the 6 is right here. So this is going to be a 2. So 2 plus 4 is 6. It doesn't matter what this value is for that. So we see 4 here. We see this 6 for sure. So what can this go up to? This can go up to 3. But it can't be a 3. Because if this was a 4, we'd only be able to see 4, 5, and 6. And that's too few. So 1 and 2. Because it can't be 3. 3's in the column already. That makes a 1, 2, 3 triple. So this is 4, 5. And it's not a 5. So that's 4. That's 5 and 4. That's 5. We get the 2 and the 4 here. We get the 1 and the 2 here. That's not a 1. I don't think I need this corner mark. So how are we fulfilling 4? We're going to see the 4, the 5, and the 6. So we only get to see one more, meaning we can't make this a 1. That would make this a 2. Oh, no, never mind. This is hidden by the 4 no matter what. So no, we don't care if this is 1 or 2. All right, maybe I'll fill these out. So this is going to be 4, 5, 6. This can't be 4. And this is going to be, 3, 4, 5. It's not 4. So this sums to 3, 4, or 5. The only way to avoid a 1... Oh, no, we could do 2, 2. Sorry, with 4. Oh, with the 3, the only way to do it is 1, 2. I'm just wondering if this has to be the 1, because obviously this can't be, but... So we're not, in this row, we're not going to see the 2, 1, or 3, definitely. So this maxes at 3. And this is going to add to 3, 4, or 5. So this maxes at 4. With a minimum of 3, we could see 3, 5. Oh, so if this is 3, this would be 5, and that would be 6. That would that would see a maximum of 3. If this was 4, that would be 5. That would be 3. We'd only see 2. And if this is 5, we only see 2. So we see exactly 2 or 3 here. We're definitely not seeing 1. Interesting. Oh, the 6 is in one of these two, maxing this out at 2. There must be more to this, right? Or maybe this one? I'm trying to figure out which skyscraper to look at. This is a 1, 3 pair. And then this is going to hide everything but the 6, potentially. So we can be up to 4. That doesn't help me. Oh, this 4, actually. I don't think we can do 4 anymore. Yeah, 4, 5, 6 would be the max. In fact, we have a 5, 6 pair here, making that a 3. So that can't be a 3. So we're not going to be 1, 2. Meaning that can't be a 2. Because if that was 2, that would be... Oh, no, sorry. We could do 2, 2, heading to 4. Never mind. Keep thinking of it as a column. So if this was 4, This would have to be 2, 2. Oh no, it could be 1, 3. Doesn't really matter, does it? Why can't this be a 3? I don't remember why I removed 3 from here. I think I have to add it back. I don't know why I removed 3. Okay, let's just think. Okay, let's add 3 back, because I don't know. There may have been good logic, but I may have just erroneously eliminated it. Anyway, let's look at this column again. Or sorry, this column. This column is going to be 2 or 3. It cannot be 4. So that's not a 4, meaning this can't be 2 because it's not going to add, because it adds to 6. So this is 3 or 4, meaning if this was a 6, would be 1, 3, 6. If this wasn't a 6, this would be the 6. Yeah, either's possible. Oh, shoot. Okay. So what is our... Is there anything I missed? Okay. 6 is definitely done. 1 is definitely done. Oh, the 5 isn't quite done yet. Ooh, okay. Yeah, unfortunately, it's either this order or this order. So this is either 1, 2 with 6, 5, or this is 2, 1 with 5, 6. So I don't know what to do with that. This 4, we're going to see this cell and the 4, 5, 6. So that's done. This sees 5, 6. We've looked at these two quite a bit. We looked at these two. All right, 2 or 3. Yeah, that just determines whether this is 4 or 5. Interesting. Okay, so here are the options. Either this is a 3, in which case this has to be... Wait, we only see these two. Never mind. This gets hidden by the 6. So whether this is 4 or 5, we only see 2. Okay, so that's a 2. This logic at the end has been a little sticky. Maybe I'm just not thinking about it right. Now that this is a 2, we either add to 4 or 5. So this is 2 or 3. Now, if I remembered why I eliminated the 3, maybe we'd proven it was 2, 2, but I don't know about that. Can this act? Oh, no, right. It can't be a 3 because the 6 is in one of these two. That was the reason. So we're 2 and 2 and 4. Sorry. When I forget the logic, I sometimes question whether I did it right. All right. So those are filled. Now this is a 2, so we have to go 5, 6. That gives us 6, 5. So now that these are in order, these have to be out of order for the 5. Gives us 2. And now this, right, we know what this is, 4, 5, 6. So this is a 3, making this also a 3. So the 6 is here, so that's 1 and 3, that's 1 and 3. And we're done, correct solution, nice. All right, sticky ending there, but yeah, I think I just wasn't thinking about it right. And I also re-added a digit I'd eliminated because I couldn't remember why. But yeah, okay. I figured it out again. Cool. Well, very nice puzzle, PjoeterBliep. Thank you for joining the team. Your puzzles have been great. And if you enjoyed this, why not leave a like, subscribe, and a kind comment below.